Hello, here's your recap video of the questions we did last two lessons. So first question we had was, I got it sideways the way you sent it to me. Which one was it? X over x squared plus 2, there we go. Given f of x equals x over x squared plus 2, given f of x is increasing on the interval, find the tangent largest, find the largest possible value of k, it says. Okay, so to do that, we differentiate it and find the turning points, so we can figure out what the increasing interval part of it is. So here we got x over x squared plus 2, use the quotient rule for that, and that's, I won't go over it again, but that generated 2 minus x squared over x squared plus 2 all squared. That's going to lead us to, that's just going to get binned away, so we get 2 minus x squared equals 0, so x squared equals 2, so x is equal to plus or minus square root of 2. Okay, which is what we get here, minus root 2 and plus root 2. So there you are, increasing, that's where the function's increasing there. What we didn't talk about is what if you need to show that it's increasing. To do that, all we do is just, if you look at the derivative, the second derivative, where at the point minus root 2, so you need to differentiate this again. Differentiate it again and then put minus root 2 in, you should find that the function is, the answer, the number you get is positive because it's increasing. It's telling you that the rate is, the rate of change of the rate of change is positive, so it tells you it goes up. So have a go at that and see if that works yourself and get back to me, just in case you need to demonstrate it. Okay, and that was it, that was all the question asked. Next one was, part B, find the exact coordinates. Yeah, I've had a little look at that. I don't understand what they're on about, even referring to the answers. 0, 0 is not a point of inflection in this question, so I don't understand. I'm mystified on that one. So maybe talk to your teachers about that one and get back to me. Let me know what's going on with that one, because I don't know. 6, given that a curve has equation y equals cos squared x plus sine x, find the coordinates of the stationary points. So we're just going to differentiate it and equate to 0. So here's one I prepared earlier. Y equals cos squared x plus sine x. I'm going to use the product rule for that element of it, cos squared x, because it's cos x times cos x. That generated minus 2 sine x cos x, and the derivative of sine x is cos x. I just wrote them in a different order so we can minimise the number of sines. Equate to 0, and what you did, I think, is that you eliminated cos, but we don't want to do that. I want to factorise it. So cos x, 1 minus 2 sine x equals 0. So that either cos x is 0 or sine x equals a half. If cos x is 0, x is pi by 2 and 3 by 2 in that interval of 0 to 2 pi, because there are infinite number of solutions to that. But just in that interval, that's where cos x is 0. And for sine x, x is pi by 6 and 5 pi by 6. So if we refer to the graph of that, which I've also prepared earlier, there we go. We have the turning point, there's a maximum there, minimum there, maximum there, minimum there. So this one will be the 3 pi by 2, this one will be pi by 2, this is the pi by 6, and this is 5 pi by 6. So there you go, there are turning points. Next question, getting ahead of myself. 6, 8, f of x is e to 0.5x minus x squared, find f dash of x, so do its derivative, and by evaluating f dash of 6 and 7, show that as a stationary point between the two, between 6 and 7. So there we go, there it is, that's the function. Differentiate it, you get 0.5 e to 0.5x, because it's a composite function, minus 2x of course. If you evaluate that by putting a 6 in there, we get 0.5 e cubed minus 12. Put a 7 in there, get 0.5 e to 3.5 minus 14. I haven't figured out what they are, but what they'll be is different signs. So let's say this turns out as positive. and this turns out as negative, which is probably the case. So that's positive, and that's negative. Then at 6, it's positive gradient. Yeah, so it's going up like that. And at 7, it's a negative gradient, so it's going down like that. So there must have been a place in between where the gradient was 0. There's no way that you can go from positive to negative without going through some area where the gradient is nothing. And that tells you there's a stationary point there logically. So you'd say the change of sign, that implies the gradient is 0 between 6 and 7. And that shows there's a stationary point between 6 and 7. Alright, next up. That's 8, so now we want 10. 10, curve C has equation y equals 2 e to the x plus 3x squared plus 2. Find the equation of the normal to C at the point where the curve intercepts the y-axis. Okay. So, there's the function, differentiate it at 2 e to the x plus 6x. At the point where the curve intercepts the y-axis is where x is 0, so that's 2 times 1 plus 2, so that's 4. And the derivative where x is 0, its gradient, is going to be 2 plus nothing, so 2. So the gradient of the normal, it will be the opposite because the tangent will be a gradient of 2. So normal is minus a half. And that's it. I know it crosses the x-axis at 4. I know the gradient minus a half. So that tells me the equation of that straight line, the normal, is y equals minus half x plus 4. Then the question itself asks you to reorganise that. So it says x plus y plus number equals 0. But I'm sure I didn't bother doing that, but I'm sure you can yourself. Next up, we've got 12. Curve as equation y equals e to 2x cos x. Show the turning points occur when tan x is 2. So y equals e to 2x cos x, differentiate that. I'm going to use the product rule again with a mixture of chain because it's a composite function. So 2e to 2x cos x minus e to 2x sin x is 0. I've just done it in one move there, and obviously I know the result, but I move sin x over e to 2 sin x, e to 2x sin x over, become positive, divided by e to 2x cos x, and that gives me tan x on the right, and just leave the 2 on the left. So 2 is tan x. Then it asks 12. Find the equation of tangent to C at the point where x equals 0. At the point x equals 0, the gradient is 2. Because if that's 0, that whole thing's 0. If that's 0, that becomes 1. And e to the naught is 1 times 2. So it's 2. That's how it's presented on your calculator, by the way. Derivative with a line and then x equals 0. So that tells us that the gradient is 2. Because it goes through x equals 0, the intercept is 0, so the line will be y equals 2x. That's it. Next question, 14. I haven't written out, it's not very long, so I'll just put page 86. So that's a message for me to go back to 86. There we go. That's why I didn't write it out again. So yeah, it's different. Let's look at the question. Find f dash of x. So differentiate x cubed minus 2x e to the minus x. So that's the product rule. So there it is. E to minus x, 3x squared minus 2 times minus e to minus x cubed minus 2x. So that's it. And then I factorise that. Remember, I noticed that that's all multiplied by e to the minus x. So instead of multiplying it all out and then having to undo it all, just notice that that's multiplied by e to the minus x. So is that. So I can just write the whole thing times by e to the minus x. But notice the sign changes because of the minus outside the bracket. So the minus x cubed plus 2x. So there you go, that's the derivative of it, that thing in degree order, x cubed, x squared, x number. And then it says the normal to C at the origin intersects C again at P. Show that the x coordinate of P is a solution to the equation 2x squared e to the x plus 4. So we figured out that the gradient, the normal, goes through the origin, so there's no intercept, and must be opposite. Sorry about the noise in the background, children. It's got the opposite gradient, so you put x equals 0 into all that, you're left with -2. So that means the gradient is y equals is a half plus a half. So the equation is y equals half x, and because it goes through the origin, there's no intercept. Well, the intercept is 0. Yeah, hang on a sec. So then, to find out where they cross, we're going to use algebra. I'm going to equate them. Half x equals e to the minus x cubed minus 3x. And then we're going to need to do some tricks to get what they're asked for, which is, I think I put on the next page. Yeah, so half x is equal to that. We can multiply it all out, but what we ended up having to do was multiply by 2 over x e to the minus x. And that was to try and get a situation where basically we've just got 4. So I changed that 2 into 4, and it's divided by x and e to the minus x and times by 2. So that's what I did. And if you do that throughout, that becomes 2x squared, and that becomes e to the x. And that's exactly what they're looking for. I think we did another question, but it was very simple. It was just a quite easy one, wasn't it? With logs, you just differentiate it and then rearrange it to make log x a subject, and then raise e. How do you say it? E to the power of it. Raise e to the. I can never remember how to say that. Anyway, that was no problem for you. So that's what you did there. Okay, mate. I'll speak to you again on Friday. Hope that was useful. This was a recap for you to watch over and over again, and I'll speak to you then.